Welcome to today's session in physics. Today we are discussing common forces and we'll be discussing how to solve problems by drawing free body diagrams by using the concept of equilibrium. Common forces in nature. In our daily life also we come across many type of forces. When we think about such forces, the first force which comes into our mind is that gravitational force. Every object attracts every other object with this gravitational force. Another force which we remember very soon, that is electric force and magnetic force. Together they are called as electromagnetic force. So in daily life situations, whatever force we come across, they belong to these two categories. When we mention the word gravitational force, actually that the actual word we use in this context, it is weight of an object. Weight of an object means the gravitational force on an object due to the attraction of earth. So in this chapter we'll be using weight. That weight means gravitational force and its expression is W equal to mg. So W equal to mg is the expression for gravitational force or weight of the object, where m is the mass and g is the acceleration due to gravity. Now electric force and magnetic force together, they are called the electromagnetic force, and which are those forces in our daily life. Actually, the forces which we come across in daily life, they can be divided into two categories: contact forces and non-contact forces. As the name suggests, contact forces are the forces which require physical contact, or the forces which arise due to physical contact is called as contact forces, and non-contact forces means there is no need of physical contact. For example, forces between magnets and all, no. Actually, even before physical contact, that attractive or repulsive force comes into action. The same with the case with the charges also. The physical contact is not needed. But on the other hand, frictional force, normal reaction, etc., they require this physical contact. So such forces are called as contact forces, which require physical contact for them to come into action. Mainly, we will be discussing the four forces. Tension force also we are discussing. Four forces as the contact forces. We have weight, normal force, and friction and tension. So the four forces which we discuss in this session, they are weight, normal force, friction and tension. What is normal force? See, as the diagram shows, when an object is kept on the surface, its weight is acting downward. So it arises due to on the table when the book is kept, that weight mg is experienced on the table due to that physical contact. That way we call this weight as a contact force. So that weight mg is acting downward, and in reaction to it, the table will be exerting a force on the book in the opposite direction, that is marked as N. See, this reaction will always be normal to the surface, and that is why it is called as normal reaction or normal force, and that is what is marked as N in the diagram. So normal reaction in the upward direction and weight is acting in the downward direction. Now coming to the next case, that is frictional force. Frictional force arises when the body slides or attempts to slide along a surface. We'll be discussing in detail about frictional force, and the frictional force will be acting parallel to a surface, and it will be acting in a direction opposite to the direction of external force. Air resistance also is a frictional force that acts upon the objects when they travel through air. Okay, and all these forces, that's what we have to keep in mind. All these forces are of which origin? electromagnetic origin. We are not proving that, but we take into granted. That means all these forces are of electromagnetic nature. Now, third one is the tension, the force of tension. I think you are not familiar with this tension. Tension arises when an object is tied to a string or a thread, something. That means consider a bucket of water tied to a rope. Okay, when you hold that bucket with the rope, you can see that there is a force of tension or stress, we can say, along the thread. It is in a stretched state. The string or the rope is in a stretched state. So that force we call as tension. And what is the direction of tension? So what I said, when we keep a thread, so the string is connected to a rigid support, and at one end of the string you have a mass of m, and because of this weight, so its weight is acting downward, weight mg is acting downward. So this rope is in a stretched state. That force which comes due to the stretched state of the string, we can call it as tension, and the tension will be acting in a direction towards the point where it is fixed. So this is actually the direction in which the tension is acting. So tension acts along the length of the string towards the point where it is fixed. That's what we can say about the tension. So tension arises when we connect some objects with the threads and keep it in stretched state. See, if it is kept in a loose form, this tension will not arise. It arises only when the string or the rope is kept in a stretched state. So that's about the main types of forces which we come across. Equilibrium. Equilibrium, according to Newton's law, it means a state when no external force is acting. That means if the external force acting on a body or a system is zero, we say it to be in equilibrium. So equilibrium state are of two types from Newton's first law. Either the body can be in the state of rest or the body can be in uniform motion. In both the case, we say the body to be in the state of equilibrium. In relation with equilibrium, we discuss three terms: concurrent forces, collinear forces, and coplanar forces. Concurrent forces means the forces which act simultaneously. Simultaneously means at the same time on a body at the same point. So the forces which are acting at the same point at the same time are said to be concurrent forces. So when forces are concurrent, all the vectors are to be added together to obtain resultant force. So that's the case. Now, collinear forces means the forces which acts along the same line or close parallel lines. Okay, such forces are called collinear forces. And coplanar forces means the forces which are acting in the same plane. So, concurrent means acting at the same point at the same time. Collinear means acting along the same line, and coplanar means acting in the same plane. Now let's discuss the concept of equilibrium in detail. Equilibrium under concurrent forces. So first we consider a particle under the action of two forces F1 and F2. This case. In that case, the particle is under the action of two forces, vector F1 and vector F2. For the particle to be in equilibrium, so those two forces are concurrent forces. For it to be in equilibrium, the vector sum of the two forces, that means vector F1 plus vector F2, should be equal to 0. Or it shows vector F1 should be equal to minus vector F2. So that is the condition for the two forces to be in equilibrium. Now coming to the second case, that means a system under the action of three forces, or a particle under the action of three forces F1, F2 and F3. The three forces, they are acting in such a way that the resultant will be equal to 0. which means that F1, F plus F2 plus F3 should be equal to 0. So for this to happen, we can say that the sum of any two forces should be equal and opposite to the third force. Then only we will attain the condition F1 plus F2 plus F3 equal to 0. In the diagram, it is given the resultant of F1 and F2 is equal and opposite to F3. So when we take the sum of resultant of F1 and F2 and F3, we'll get the result to be equal to 0. Anyway, the condition remains the same, that is F1 plus F2 plus F3, that is equal to 0, vector sum. We can extend this to any terms and forces if it is there. We can write like F1 plus F2 plus etc. plus Fn is equal to 0. All these are vector sum. That's what we have to keep in mind. So that is the condition for equilibrium under the action of concurrent forces. Now, in the case of concurrent coplanar forces, that means the forces are acting in the same plane. So in the case of coplanar forces, each force can be resolved into two components, x and y. So if an object is in equilibrium under the two or more concurrent forces, the algebraic sum of components of forces in any two mutually perpendicular directions should be 0. Any two mutually perpendicular directions, we can stick on to two directions, x and y directions. That means the forces should be balanced in x and y directions separately. So the algebraic sum of forces in x direction should be equal to 0 and algebraic sum of forces in y direction should be equal to 0. Then only we can say that the particle is under equilibrium. So when the forces are acting in a plane, we have to consider the two components separately, or the forces should be balanced in x and y directions separately for the particle to be in equilibrium. That means algebraic sum of components in x direction, that is fx, should be equal to 0, and algebraic sum of components in y direction, that is fy, should be equal to 0. So for equilibrium of two or more forces, net Fx should be equal to 0 and net Fy also should be equal to 0. It simply means the forces should be balanced in x and y directions separately.